We will now solve problem number 32. Problem number 32 is a particle of mass m and charge q is placed at rest in a uniform electric field E and then released. The kinetic energy attained by the particle after moving a distance y is. See, according to the problem, a charged particle of mass m and charge q is placed at rest in a uniform electric field E and then released. The kinetic energy attained by the charged particle is, you need to find out what is the kinetic energy attained by the charged particle. It is said that the particle has got mass m, charge q, it is placed in a uniform electric field E. Let us suppose this is a uniform electric field E in which a charged particle Q is placed, right? And it is said that in this electric field, this charged particle travels a distance equal to y. You need to find its kinetic energy. See, whenever it comes to the problem of kinetic energy, always try to make use of work energy theorem. See, work energy theorem says the change in kinetic energy will be exactly equal to the work done by the force. See, initially the charged particle was at rest, so its initial velocity was 0. Then the electric field was switched on and the charged particle starts moving. So it gains some velocity, say v. So its velocity has changed from 0 to v. So its kinetic energy must also have changed. Initially its kinetic energy was 0. Finally its kinetic energy will be half mv square. So what is the change in kinetic energy? Change in kinetic energy is half mv square. Right? Change in kinetic energy is half mv square. That must be equal to work done by the force. We know work done is force into displacement. Work done is force into displacement. So the change in kinetic energy, we are asked to find out kinetic energy. So we'll write it as it is. Half mv square anta bariyadu onde, change in kinetic energy bariyadu onde. You know what is electric force experienced by this charge placed in the electric field? Electric force experienced by a charge placed in electric field is EQ. And what is the displacement of the charge? Y. So the kinetic energy acquired by the charge placed at rest in an electric field is EQY or QEY. So this must be the option. This is the kinetic energy attained by a charge. What is important in this problem is to remember, whenever you are asked to find out change in kinetic energy, you are said that a particle is initially at rest and then it moves certain distance. If it is moving certain distance, it must have acquired some velocity. Initially its velocity was 0 and now it has acquired some velocity. That means there is a change in kinetic energy. There is a change in kinetic energy. ಎಲ್ಲೆಲ್ಲಿ ನಿಮಗೆ kinetic energy change ಆಗ್ತಿದೆ ಅಂತ ಹೇಳ್ತಾರೋ ಅಲ್ಲೆಲ್ಲ you try to make use of work energy theorem which you have learnt in first year. Work energy theorem is to be made use, right? According to work energy theorem, change in kinetic energy will be exactly equal to work done. This is work energy theorem. So the option here is